In addition to performing automated sidechain predictions, another way to improve sidechain fit is to use Maestro's Rotamer tool. First, open the Density Fit panel and click on the top of the sidechain fit column to sort the table according to the quality of sidechain fit. We'll click on the row for residue 274, the entry in the table with the worst sidechain fit, and Maestro will automatically zoom in on it in the workspace. Before we use the Rotamer tool to fix the sidechain, though, let's take another look at how we can center residues and density maps in the workspace. First, we'll zoom out and fit the entire structure in the workspace by clicking on the Fit to Screen button in the Maestro toolbar. To zoom in on residue 274, we can open the Find panel, which is available under Maestro's Edit menu, or by pressing Ctrl F. Under Find Types, we click the toggle for residue, then enter 274 in the residue number field. One important thing to be aware of when doing this is that if your protein has a chain name, it needs to be entered into this panel's chain name field in order for the residue to be found. We click on the Find button, which causes Maestro to center residue 274 in the workspace, and we can walk along the backbone by pressing either the N or the P buttons on our keyboard, which will center the workspace on the next or previous residue, respectively. With residue 274 centered in the workspace, we can turn off the green Find marker by unchecking the Mark Principal Atoms toggle in the Find Atoms panel. So having located residue 274, the next thing we'll need to do is to select alternate conformational states for the sidechain, which may result in an improved density fit. We'll dismiss the Find Atoms panel and open the Rotamer tool by right-clicking on the residue and selecting Rotamers from the drop-down menu that appears. In the Rotamers panel, the table is populated with all of the common conformational states for this residue, and we can manually scroll through these residues just by using the up and down arrow keys. We can restore the original conformation by clicking on the appropriately named button here, or automatically calculate and choose the best fit by clicking on the Choose Best Fit button. Occasionally, the best fit sidechain placement may not be a perfect fit. The table can be sorted according to fit quality by clicking on the fit column header, and clicking on the second or third best fit conformational state may produce a preferable alternative. There are a couple of other tools that are useful for manually manipulating sidechains as well, one of which is the Local Transformation tool. Let's dismiss the Rotamer tool and give it a try. To perform a local transformation, we'll first lasso the atoms in the workspace that we wish to manipulate. Then, we'll click and hold the Local Transformation button in the Maestro toolbar, and choose Global Local from the drop-down menu that appears. This opens the Advanced Transformations panel. We'll press the Selection button to tell Maestro to use the lassoed atoms for local transformation, and of course we'll ensure that the transformation mode is set to local. Finally, we'll manipulate the selected atoms just as we would change the workspace view. So once we're satisfied with the placement, we can turn off local transformations by closing the Advanced Transformations panel. To clean up the geometry without regard for density maps, we can simply click on the soap bar icon in the Primex toolbar. Now we can also perform local transformations without opening the Advanced Transformations panel at all. We can manipulate individual residues by holding down the Local Transformations button on the toolbar and choosing Residues from the drop-down menu that appears. This activates local transformation mode, and we can now move individual residues. Alternately, we could have entered local transformation mode simply by pressing and holding the space bar. Finally, there's one more helpful manipulation tool to be aware of, and that's the Peptide Plane tool. To use it, we'll just press and hold the Adjust button in the Maestro toolbar, and then select Peptide Plane from the drop-down menu that appears. Next, we'll click on an atom in a residue's peptide group to select that residue's peptide plane for manipulation. Once the peptide group is selected, a marker appears, and adjusting the peptide plane is a simple matter of clicking and dragging. Once we're satisfied with the changes, we can click on the Adjust button in the Maestro toolbar to stop using the Peptide Planes tool, and the workspace manipulation returns to normal.